So how does an app go from just a few friends using it to millions of people all around the world? That's not just a cool question. It's one of the absolute core challenges you'll get in a system design interview. And let me tell you, the answer is never just buy more servers. It's this really fascinating step-by-step evolution. You find what's breaking, and you make smart, deliberate choices to fix it. Let's walk through that journey right now.
All right, picture this. You're in the interview, the pressure's on, and you get this question. It's huge, it's open-ended, and it's kind of scary, right? Well, that's on purpose. They don't want the perfect final answer right away. What they really want to see is how you think. Can you take a huge problem and break it down step by logical step? That's exactly what we're going to do here. We're going to build a system from the ground up, just like you would in a real interview.
Here's our game plan, and we're going to start at day 0 with the absolute simplest setup you can imagine. And then we're going to evolve it. We'll find a bottleneck and we'll fix it. We'll separate our services, add some serious speed, figure out how to handle tons of traffic, and then take our little app global. And at the end, we'll talk about the most important part, the mindset that ties all of this together.
Every big idea has to start somewhere. And in the world of software, that somewhere is almost always right here. One single, humble server trying its best to do absolutely everything. Let's take a look. So on day 0, you've got it all. Your web app, your logic, your database, all just living together on one computer. And you know what? For your first 10, maybe even 100 users, this is great. It's cheap, it's easy to manage, it just works. But the moment you start to get popular, that beautiful simplicity becomes your single biggest liability. And that liability has a name, a really important one you need to know for your interviews. It's called a single point of failure, or SPOF for short. In our setup, that one server is the entire system. So if that box goes down, maybe the power goes out, the hard drive fails, or it just gets overwhelmed with traffic, your entire service is offline. Poof, gone. And this right here is the perfect picture of that danger. See that one component in the middle? If it fails, everything stops. In an interview, the moment you point this out, that you've identified the first SPOF, you're showing the interviewer that you're already thinking about reliability and risk. So, the obvious next question is, how do we fix it?
Okay, so our first big move is a classic, divide and conquer. We need to break things apart. And the most logical first split you can make is to separate the part that talks to users from the part that stores the data. Let's see what that looks like.
Okay, check out this new setup. It's a huge step up. We now have what we call a web tier and a data tier. And this separation is huge because it gives us incredible flexibility. Now, if we get a flood of web traffic, we can just beef up the web server without even touching the database. Or if the database is the one getting slow, we can upgrade it all by itself. This is really the first major step towards building a system that can actually scale.
So as soon as you make that split, you're faced with your next big architectural decision. We have a dedicated server for our database, but what kind of database are we actually going to use? This is a classic fork in the road, and the choice you make here has some major consequences down the line. You've basically got two big families to choose from. On one side, you've got relational databases. You've probably heard of them as SQL databases. They're the tried and true workhorses that store data in neat, structured tables with rows and columns. Then you have the other camp, NoSQL. These are way more flexible. They can handle all kinds of unstructured data. Documents, key value pairs, you name it. The big trade-off? SQL is fantastic for complex queries and ensuring consistency, while NoSQL often prioritizes raw speed and massive scale.
So how do you decide? Well, you'd probably lean towards NoSQL if you need absolutely lightning-fast performance, or if your data is messy and doesn't fit into neat tables. Also, if you're just storing and retrieving big chunks of data like JSON, or you know you're going to have a truly massive amount of data, NoSQL is often the right call. For most other cases, though, a good old relational database is still a rock-solid choice.
Okay, so we've split our tiers, we've picked a database, but as we get more and more users, people start complaining that the site feels slow. The bottleneck has moved again. Now it's our database that's sweating, struggling to keep up with all the requests to read data. The first tool we pull out to solve this is called replication. It's a really clever idea. We make several copies of our main master database. We call these copies replicas or slaves. All the writes, any new data, still go to the one master database to keep everything consistent. But the reads, which are usually way more frequent, can now be spread out across all those replicas. This gives us a massive performance boost. And we get a huge bonus, better reliability. If one of our database servers completely dies, the others are still there to pick up the slack.
But even with replicas, hitting a database still means reading from a disk, and that's just not as fast as reading from memory. So for the stuff that gets accessed all the time, like a user's profile page or the top 10 trending articles, we can do even better. And that's where a cache comes in. Think of it like a super fast cheat sheet for your app. It's a layer of high-speed memory that sits right between your application and your database.
Now here's a huge tip for your interview. It's not enough to just say, let's add a cache. You've got to show that you understand the trade-offs. So you should be asking questions like, how long does data live in the cache before it's considered stale? How do we make sure the cache and the database don't get out of sync? What's our plan for when the cache server itself fails? And what happens when the cache gets full? Mentioning a specific eviction policy like LRU, least recently used, shows you're thinking at a much deeper, more practical level.
All right, our cache and replicated databases are humming along, handling all the data requests beautifully. But guess what? The bottleneck has just moved again. Now our single web server is getting absolutely hammered with traffic, and it can't keep up. We just need more raw computing power.
So we have two fundamental ways to solve this. First, there's vertical scaling, or scaling up. That's like taking your one server and making it a super server. More powerful CPU, tons more RAM. It's like putting a bigger engine in your car. But at some point, you're going to hit a hard physical and cost limit. The other way, and this is how modern systems are built, is horizontal scaling, or scaling out. Instead of one giant server, we use a whole bunch of smaller, regular servers and add more as we need them. This is the real secret to achieving massive, almost infinite scale.
But wait, if you have a whole fleet of web servers, how does a user's request know which one to go to? Well, that's where a load balancer comes in. You can think of it like a traffic cop for the internet. It sits in front of all your web servers, and its only job is to take every incoming request and direct it to the server that's least busy at that moment. This little device is what makes horizontal scaling possible.
Okay, our system is fast, it's reliable, it can handle a ton of traffic. We're feeling good. But all of our servers are sitting in one building, let's say in Virginia. What happens when someone in Japan tries to use our site? Well, physics gets in the way. The speed of light is a very real, very hard limit. And that physical distance creates lag or latency that makes the site feel slow no matter how powerful our servers are.
The first way we fight this is with a content delivery network, or CDN. This is an easy win. A CDN is just a huge, global network of servers that caches your static content, things that don't change often, like images, videos, or style sheets. So now, when that user in Japan requests a photo, they don't have to fetch it all the way from Virginia. They get it from a CDN server that's right there in Tokyo. The difference in speed is absolutely massive.
And here it is. This is the grand finale. This is what our system looks like now, fully evolved to serve millions of users all over the world. Notice, we don't just have one server location anymore, we have multiple data centers. A clever service called GeoDNS automatically directs users to whichever data center is closest to them. And inside each of those data centers, you'll see all the pieces we've just put together. A load balancer, a farm of web servers, that crucial caching layer, and our replicated databases. This is what a modern scalable system really looks like.
So we did it. We designed a system that can scale to millions. But honestly, the specific technologies, the load balancer or the type of database, that's not the most important takeaway here. The real goal in a system design interview is to demonstrate your thought process. And that process is really just a simple, powerful loop that you can apply to any problem. You start small. You identify the one thing that's holding you back right now, the bottleneck. Then you propose a clear solution to fix that specific problem. You talk through the pros and the cons, the trade-offs of your solution, and then you just repeat. Because as soon as you fix one bottleneck, the system grows, and a new one will eventually appear. This iterative process, this is the scalability mindset.
And that brings us right to the final and maybe most important question. We've built this amazing globally distributed system, so we're done, right? Not even close. At millions of users, what's going to break next? Maybe it's how you split up your data across databases. Maybe it's how all your different services talk to each other. The point is, the work is never really done. System design is a continuous journey, not a final destination. And showing you understand that is how you really knock that interview out of the park.